All right. Hi, all. Welcome to Clean Testing. I'm Jason Taylor, and I'm an SSW Solution Architect. You can find me on Twitter at JasonTaylorDev. So recently I've been teaching folks about clean architecture as the simplest approach to enterprise application development with .NET Core. Today, in this talk, I want to highlight a simple and yet powerful approach to automated testing with .NET Core. I'll demonstrate an approach with tests that are easy to create, maintain, and understand, and I'll give you the confidence to deploy your system to production, knowing that it will behave as expected. So today we'll start with a brief introduction to clean architecture, and following that, I'll provide an overview of the clean testing approach. Next, we'll take a quick look at some testing tools before we dive into the live demos, and this is where we'll spend most of our time. Finally, I'll wrap it up with some resources for those of you who are keen to learn more. With clean architecture, the domain and application layers are at the center of the design. This is known as the core of the system. The domain layer contains enterprise logic and types, and the application layer contains business logic and types. Now, core should not be dependent on concerns such as data access and infrastructure, so we invert those dependencies. Therefore, infrastructure and presentation depend on core. Now, this is achieved by adding interfaces or abstractions within core, which are implemented by layers outside of core, such as infrastructure. All dependencies flow inwards, and core has no dependencies on any other layers. Infrastructure and presentation depend on core, but not on one another. Now, this results in an architecture and design that is independent of frameworks. It doesn't require the existence of some framework. It's testable. That's why we're here today. We're going to see just how easy it is to test a system that follows this architecture. It's independent of the UI. Right now we might be using Angular, soon we'll switch to Blazor. Independent of the database, it might be based on SQL Server, you might prefer Postgres, you can switch it to Cosmos DB without trouble. Finally, it's independent of anything external. In fact, core simply doesn't know anything about the outside world, and that's what makes this architecture and design so brilliant. It's the difference between an application that will last 3 years and one that will last 20. Now, if you'd like to learn more, please check out my Clean Architecture with ASP.NET Core talk, which I gave at NDC Sydney last year. Next, clean testing. Before we dive right into the details, I wanted to give an overview of the typical approach. So with the typical approach to automated testing, we have focus on unit tests, integration tests, and UI tests. No surprises there. We know that UI tests are the most expensive to create and maintain, and that they're also the slowest to run. We therefore minimize the amount of UI tests that we create. In the middle, we have integration tests, and at the bottom, we have our unit tests. Now we know that unit tests are cheap to create and maintain, and the fastest to run, and so this is where our main effort is focused. So generally, you'll write a unit test first. If you can't write a unit test, you'll write an integration test, and where an integration test won't work, you'll write a UI test. If logic exists in the front end, then UI tests will be required. If logic exists in the API layer, then maybe you'll need some ASP.NET Core integration tests. Of course, with the clean architecture approach, we're trying to keep logic out of both of these places. But we're here to talk about clean testing. With the clean testing approach, we're going to add subcutaneous tests into the mix. We'll still write unit, integration, and UI tests where appropriate, but the main focus will be on subcutaneous tests. And that's because these tests are easy to write and run. These tests effectively verify behavior and integration. They document the system and reduce the need to create and maintain a large number of mocks. In short, these tests are going to provide us with a great deal of confidence. So what are subcutaneous tests? The subcutaneous tests are the tests that operate just below the UI layer. Now, this can be interpreted a number of different ways. So say, for example, if you were building a single page application with an Angular front end and a web API backend, in that case, just below the UI layer could be the API if there was logic worth testing in the API. However, with the approach that we use in clean architecture, there's no logic in the API. So we go one layer deeper. We go into the core layer, into the application layer where we have our commands and queries, which are the entry points to our application. So we'll use subcutaneous tests to verify the basic inputs and outputs of the system. And this provides us good test coverage and helps to ensure that our tests are not brittle. We just want to test the basics. Now, these tests are only appropriate if we keep logic out of the UI, which we do with the clean architecture approach. And this will therefore reduce the need to write expensive and slow UI tests, as subcutaneous tests are going to cover a lot of that behavior anyway. So let's look at this from a different perspective. We can see in the presentation layer that contains the UI. So for a SPA, as I mentioned, it might be an Angular front end with a Web API backend, or maybe it's just a microservice with a Web API backend. In core, which includes the application layers and the domain layers, that contains all logic. We'll be testing our commands, queries, validators, and other cross-cutting concerns. Within infrastructure, that represents both the internal infrastructure and the external infrastructure. As an example of the internal infrastructure, you can think about the database. We'll be writing these tests against a live database. For external infrastructure, think about an external client API, such as some web service that you're accessing. So these subcutaneous tests that we write, they're going to operate from the core layer all the way down to the underlying database. But we're going to exclude external infrastructure. So just to ensure that we're on the same page, we're going to test commands and queries. Those are the entry points to our application. We're going to include internal services, and they'll be configured as closely to production as possible. We're going to mock our external services. Hopefully we don't have too many mocks. It should be only used for external services, such as our external API client. And most importantly, we're going to keep it simple because these tests should be easy to write and maintain. So now let's have a look at some testing tools, starting with testing frameworks. The frameworks I considered when putting together this approach were NUnit, a popular choice by many .NET Core and .NET developers. It's probably the most widely used. XUnit, a very popular choice with .NET Core developers. Next, there's MS Test. We all know and love MS Test. I think it's a default choice for many new developers, but most people are using NUnit or XUnit. Now, that's a logo that I created for MS Test. They don't have one. Created a few logos in the past. This is my favorite one so far. I hope they like it. And finally, we have Fixie. Now, Fixie is a relatively new framework. It's kind of a powerful convention-based test framework. Now, I couldn't test all of these, but I did create many subcutaneous tests for NUnit, XUnit, and Fixie. I probably should have tried MS Test. I know there's been a lot of work put into it. It's cross-platform and fast. Perhaps that's something that I'll try next time. And so which framework did I go with? Well, while it's possible to write great subcutaneous tests in these frameworks, in the end, I decided to run with NUnit. For this style of testing, I found NUnit to provide the best support. It was simple. It seemed to be a little bit faster. I didn't benchmark it, but I did feel it to be a little bit faster than, say, XUnit or Fixie. And it had great mechanisms for managing global state. And that was really the key for me. Writing these style of tests, having those global mechanisms is a big help. All right, so now moving on to some tools. First and foremost, we have fluent assertions. So this tool contains a large set of extension methods to allow you to more naturally specify the outcome of a test. It also improves your readability within tests, so it makes your tests easy to understand. And that's one of the goals of this approach, making these tests easy to understand, a little bit of a form of documentation within your system. So not only that, one of the greatest things about fluent assertions is that it clearly explains the test failure results. You get better results, and this means that you're going to spend less time in the debugger. So how many times do you see a test fail and you jump straight to the debugger because you don't really have enough information to resolve it, kind of without hitting that breakpoint? I find I'm doing that less and less with fluent assertions, as it provides enough information in those test results, so I get to skip the debugger and go straight to resolving that issue. Overall, I've found that fluent assertions help to improve my productivity and simplified my approach. It's a great tool. Next, we have mock. So I don't think mock really needs an introduction, but just in case, it's a mocking framework for .NET. It's really the default choice for many developers. Now, according to the repo, it's very popular and friendly. Now, you only need to check the NuGet stats to see that it's popular. I'm not sure about friendly. It's never welcomed me in the morning or commented on how nice and clean my code was, but certainly popular. We can give it that. So that aside, it does support mocking classes and interfaces. It's strongly typed, so there's no magic strings, and it's very simple to use, no prior knowledge required. And that's what I love about this tool. Next, we have Respawn. This is my favorite new tool. Like all good things, it's either recommended by or created by Jimmy Bogard. This particular tool was created by Jimmy. Respawn is an intelligent database cleaner for integration tests. What it does is instead of deleting the data or rolling back the transactions so you can reset your database back to a clean state, is it just resets the database back to a clean checkpoint. It takes a performant approach by working out the relationships among the tables and deleting the data in the correct order. It's easy to configure. You can set it to ignore tables and schemas, such as the EF migrations history. We'll be taking a look at that. And it supports many databases such as SQL Server, Postgres, and MySQL, to name a few. The best thing about Respawn, like some of the other tools that we're looking at, is that it's really easy to learn. And I'm going to show you a lot in this talk. All right, the demos we're going to be doing today will be all built using the Clean Architecture Solution template. So this is a template that I built once I had a really good understanding of the type of solution that I wanted to build and how I structured it. So it's a .NET Core template package. You can install it from the command line, run it from the command line. It's using ASP.NET Core 3.1, Entity Framework Core 3.1, and Angular 10. If you want to install it, you just run .NET new install Clean Architecture Solution template from the command line, and then you can simply run .NET new CA solution, and that'll create the project for you today. Now, we're going to write the demo using that Clean Architecture Solution template. The only difference is that I've deleted the test projects so we can create them ourselves. So let's have a look at that now. So here's the project, it's ready to go. You can see there's the domain, application layer, infrastructure layer, and web UI representing presentation. And down here we have a brand new NUnit test project, and it's called application.subcutaneous tests. I've got a single test, we'll run that to make sure everything's working nicely. That's passed, very quick. And we'll just have a quick look at what we'll be testing today. So this is the application, it's got some standard examples from the ASP.NET Core template. And I've also added my own to-do component. This one's a little bit better than most of the to-do lists you see out there because it supports multiple lists. So the most important task list, we can go back and change the title if we want to, or delete the list. We can add a new item to this presentation. We can edit items, and we can edit the details. Things like that, delete things, set priorities, all that sort of stuff. So we're going to test some basic behaviors on that. We'll test this view, generating this view model. We'll test actually creating a new to-do list and updating a new to-do list. So the first test that I'd like to write is the get to-do list query. So that is this one in the get to-dos query. So everything in the system has been represented as a query or a command. This particular query doesn't have any input for it to run, but we could add input later if we wanted to. So we could add some, say, filtering, some pagination, sorting, that sort of thing, whatever it was that we needed for this particular query, but this one's a lot simpler. It's quite basic. We inject the DB context and IMapper for AutoMapper, and we generate a new to-dos view model. So here we generate the priority levels by reading the enumeration, and we generate the list of to-dos, which also contains the list of to-do items. All right, so I like to follow the same structure in my test project as I do in my real projects. So I'm going to create a to-do list folder, a queries folder, and a get to-dos query test project. So let's do that now. I've got a nice little tool, Shift F2 to add a new file, to-do lists, queries, get to-dos query tests. Actually, we'll just call it get to-dos tests, representing more of a feature than the actual class. There we go. Okay, now I've got a stub for that, so I'll grab the stub so I don't have to type too much. Okay, here we go. All right, so this is how we'd like the test to work. We basically want a new upper get to-dos query. we want to send it away, get the result, and assert on that. But we want to do that with our production services. We want to make it as close to the production scenario as possible. So I need to bring in a few references. We'll bring in NUnit. I need a reference to the get-to-dos query. That's obviously an application. But as I mentioned, we're going to wire up production service, and they are within the WebUI project, within Startup, where we have the configure services method. So we're going to reuse that configure services method for services. So instead, we'll add a reference to the WebUI and a project reference, WebUI, and of course, WebUI represents the references the application layer anyway. So now we can bring that in. There we go. I need to install some packages, Fluent Assertions, Mock, and Respawn. So we'll just do that from the command line. So Mock. Fluent Assertions. Oh, yeah, I should have saved my CS project before I did that because it's kind of created this nasty backup file. So I'll just go ahead and delete that and we'll run that again. There we go. There we go. Mock. And Fluent Assertions. And Respawn. Okay, so let's bring in the namespace for Fluent Assertions. Yes, a second. There we go. Didn't bring it in. Let's give it another second chance. That's better. We'll clean up that. Okay, so we're ready to go. So all we have to do now is implement this helper method called sendAsync. And of course, you're wondering, what does sendAsync do? Well, it's going to actually use Mediator to send this query through and find the handler and execute the handler. Now, we could, of course, just new up the query in the handler and run handler.handle method, but that's going to miss one very important thing, and that's the fact that we have a whole pipeline of cross-cutting concerns. So, for example, we have a validation behavior right here. And if we don't run it through Mediator, this validation behavior is not going to execute, so none of our queries and commands will be validated. We've got an unhandled exception behavior, a login behavior. So we want all of those to form part of our test, to be as close to that production scenario as possible. And there's one other thing I need to do as well. Oh yeah, look at these assertions. It kind of looks like we're going to be relying on some kind of global data there. And we don't want that to happen because, you know, for this test, we might need one less than 6 items, but someone else is going to write a new test down the track and they're going to change this global data and it's going to break a whole bunch of tests. So let's set up our data here as part of the test. I've got a snippet for that. There we go. So now we're going to create our to-do list and the to-do items as part of the test. Bring in those. We've got a new helper method, addAsync, which will add it to the underlying store. And then we'll assert on those results. So we're not going to be dependent on global data. So it'll only be if we want to change it here. So I need to add in those helper methods. To do that, we want to do two things. We want to create a new class to wire up the production services and to implement those helper methods. And we're going to call this testing.cs, and it's going to be an abstract class. And we'll just put it in the root of the project there. Now, I mentioned that NUnit has really cool functionality for managing global test resources, and it's using the one-time setup. So this is going to be run for all tests, which is really great. Okay, so subs for our helper methods as well. There we go. We'll bring in Mediator, and that's fine. It's just saying we've got no await. So back in our get-to-dos tests, we can bring in a reference to testing. We could say testing.addAsync, but we can actually use the using static directive. Now, the using static directive allows us to access the static members within testing without needing to specify the type name. So you can see that being resolved. Back over here. Oh, we can delete this unit test one. We don't need that. So we've got the skeleton in place. So let's flesh that out by registering our services. So first we're going to need to, kind of wire up the database. And for that, the first thing we'll need is app settings, because that contains all of our application configuration. So I'm just going to drag that across and we'll just modify it slightly. We'll delete that one. From here, I need to get some identity server configuration, just to say that the key we're going to use is development. We're not going to require an SSL because the environment is in development. So I can put that in here, just like that. And then up the top, I've got this use in memory database is equal to true. And that's just a little feature of the template to make it easy for people to get up and running. I'm going to change the name of this database. We'll have clean testing DB for our web UI, and we'll have clean testing DB _ tests for our tests. So that's enough for now we can go ahead and wire up our configuration. So grab a little snippet. And so you can see we're just using the configuration builder, referencing the current directory, referencing the app settings file. Nice and easy. And I just want to create this field. I don't think, yeah, we'll create that ourselves. There we go. Okay, next we have the services to wire up. So we'll need the configuration for that. So let's get services wired up. So var services equals a new service collection. Easy. And reference to startup equals new startup. So that's in web UI. And remember, that's where we're going to get our service registration from, because it contains the, of course, very helpful configure services method where everything is going to be wired up. So we'll reuse that. And then we just simply say, whoops, startup.configure services and pass in our service collection. If only it could be that easy. Actually, if we were to run that now, we'd get an object reference error. And that's because when it tries to register the identity services, it actually requires a iWeb host environment. So to solve that, because we're not going to be doing ASP.NET Core integration testing and having that environment up and running, we're just going to create a mock. And we need to do it before we call configure services. So we'll do it right here. So services.add singleton mock.of. We'll bring in the namespace for mock. iWeb host environment. Just like that. And by reviewing the source code, I was able to find that we simply need to specify, the environment name, which will be development, and the application name, which will be clean testing.webui. There we go. Okay, so that's in place. Now the next thing is that we want our tests to be as isolated as possible. So we'll use an iService scope factory for that. And this will be quite similar to how it would operate under ASP.NET Core anyway. So scope factory equals services.build build service provider dot get service iService scope factory. There we go. Okay, so with service registration complete, or actually we'll just add this field. A little bit of help, we'll just make it static. Okay, so now that that's complete, we can flesh out our add async and send async helper methods. So first we'll grab a scope. Oops. We'll grab our DB context. Good. And we can simply call context.add and entity framework call. We'll figure out what type of entity it is and where to add it. So that makes our life very simple. Save changes async. Oops. There we go. All right, so now we need to wire up send async. A little bit of code from there. We're going to grab mediator. And we'll simply call await. Actually, we'll return the result, await. Mediator.send, whatever the request was. Okay, that's looking good. Let's run this now and see if our test passes. Just press Ctrl-RT. It failed. System.o could not find clean testing.webui. Wow. That's interesting.
There's a typo in the name.
Yeah. Where is the typo in the name?
Double E. Clean.
Yeah, I see that.
Line number 38.
38. Thank you. In testing.cs. This. Thanks. I was thinking, where can I have a typo in the name for assembly that I'm referencing? I forgot we were specifying the application name. Is that Dinesh?
No, Pranav.
Oh, okay. Thank you very much. All right, so we'll run it again. Fingers crossed. Yeah, thanks for picking that up. I would have fumbled around for a little while looking for that one. So there we go, it passes, which is awesome. However, if we run this a second time now, it's going to fail. And that's because we're inserting data into the database, but we're not cleaning up after ourselves. So it says, expected result.list to contain one item, but it found two. So let's use respawn to fix that. So in our testing.cs class, we can do that by creating a new checkpoint. It's so simple to create. Checkpoint. And we just specify the tables or schemas to ignore. We only have one thing that we want to ignore, and that is the entity framework migrations history. Okay, so that's not very clean. There we go. Bring in a field for that. Oh, that would have been another mistake. Oh boy, there we go. That looks good. And we'll just make that static. I also want to add a little bit of a helper method. That testing database already exists, which is not always going to be the case. So let's just add a ensure database method. Okay, so that will create the database if it doesn't exist and also run the migrations. I'll paste that one in. Here we go. So it grabs a new scope, gets the context and calls database.migrate. And for that, we need a reference to entity framework call. Wonderful. And we'll need to create our reset state method. And so putting that here, public static async task reset state. And this is an asynchronous method, so we just await checkpoint.reset. And so we want to run this before every test. Of course, we could run it after the test as part of cleanup, but sometimes our tests don't complete. Sometimes they fail. Sometimes we're debugging and we stop early. And so the cleanup might not take place, but we know the setup's always going to take place. So we clean up the database as part of setup, and then we know that we have a clean state whenever the test runs. So to do that, we're going to create a test-based class. So we'll call that testbase.cs. And I will paste in a snippet for that to save us some time. Just like that. So we've got our using static directive to testing, bring in the namespace for setup, and you can see all we're doing is calling reset state from testing. And so to associate that with our test class, we can just derive from test base. There we go. So we have the test setup logic. Okay, let's run those tests again. So we're expecting it should clean up the database, delete those two lists that already exist, and the test should pass. There we go. Great. So we can run that as many times as we want, and we'll always get a clean state for the database. All right, so now let's test one of our commands. So we've got the create to-do list command right here. You can see it has an associated validator, which is going to check that the title is not empty, that it has a maximum length of 200 characters, and that it must be a unique title, which is going to go off to the database and make sure there's no other to-do list with that title. Over here, we can see the DTO to make the request just accepts a title, and that essentially it's just adding that entity to the database. So nice and simple. So let's create a test class for that. There we go. So mirroring that structure that's in the application layer. And I will put in the stubs for all of those tests. I'll bring in using static testing. There we go. Bringing in NUnit. Okay, so the first test that we're going to write is should require minimum fields. This one's really easy to write, but it does something very interesting. And that is, it doesn't test the command handler, it actually tests the validation pipeline. So to have an invalid create to-do list command, we need to specify an invalid title. And of course, if we don't specify a title, it's going to be null. So then we can add, use fluent assertions.actions, which provides a very nice invoking method, which we can use to assert on an exception. So we'll simply pass the command to our send async method and say that it should throw, and the exception it will throw will be a validation exception, and it needs to come from application common exceptions rather than one of these other many validation exceptions, because it's our validation exception. And that's it. So if we run that, hopefully we get a pass. There we go. So that passed, and it was pretty quick. So yeah, that jumped into the validation behavior, which basically will inject any validators associated with the request, in our case, the create to-do list command. If there are any validators, it will run those validators. If there are failures, it throws the validation exception. So we were testing that, and that worked quite well. So we also want to ensure that it has a unique title. Now, to do that, we need to do a little bit of setup because we've got a blank database, right? So the first thing that we want to do is actually, we'll do that one. So the first thing that we want to do is to create a new to-do list so that when we create a second to-do list, it will throw the validation exception saying the title's not unique. So we can use some of our helper methods, and we're choosing to use send async here so that we can use the create to-do list command. The alternative would be we could say await add async and just add the entities directly to the database. But in actual fact, this way is better because it allows us to use the system that we've created in the way that it was designed to be used. And so we're testing a little bit more just by doing that. So we're going to go and give this a title, and we'll be boring and call it shopping. So that's going to send that to Mediator. If it's a valid command, Mediator will go ahead and create that new shopping to-do list in the database. So now we will set up ours, which will be a new command. So new create to-do list command. And of course, we want it to fail. We want it to hit the validation. So we'll give it the same title, shopping. And now we can use this fluent actions.invoking helper to assert that the validation exception is thrown again. So actually, we'll just grab that. There we go. So if we run that, this will be ensuring that the validator is checking for a unique title and that this little tiny bit of behavior here is working. So that's good, and it passed. So finally, we want to create a should create to-do list test. Now this one's a little bit more involved. Let me grab it and walk you through it. So the first thing it's going to do is to grab a user ID using this helper method. Then it's going to set up the command, send the command, get an ID back, retrieve that using a new helper method from the database, and assert on the actual record that was created. So what we can do is start by adding the new find async helper method. And of course, we'll add that into our testing helper class. I think we'll put it just here. So it's generic, which makes it quite easy because we can use the generic version of the EF core find async method, passing in the primary key, and that will return the result. So you can see in the test, we also had this run as default user async, and this method allows us to work with ASP.NET Core identity to create a user in the database with a valid user ID. And so that user ID is going to be used when we assert that it was created by the right user. So we'll set this up within testing.cs as well. And grab a snippet. Okay, so we have this method, run as default user async, which calls run as user async. So you see we're setting a default username and password, and it's using ASP.NET identity to go ahead and create that user in the database. And we set the current user ID to the static field, current user ID on this class. Now, the system is going to actually retrieve the current user ID using the iCurrentUser service. So we need to replace the registration for that service so that it actually uses this value, which is going to represent the current user service for us. So to do that, we need to first remove the existing registration just here and replace it with our own mocked registration that references the iCurrentUser ID. So I'll grab the code for that. And here it is. So we find the existing registration, we remove it, and then we add a new registration, which is a mock of iCurrentUser service. And you can see it just passes user ID as current user ID. Okay, wonderful. That's work. Okay, now we need to do one other thing. Remember, before each test run, the database is being cleaned up, and that means that that user is going to be deleted, which means that we need to reset current user ID back to null, so that we're not writing tests thinking that there is a valid user. So we'll put that in here. Current user ID equals null. It's reset before each test. So let's go back and run that test. And it passes. So you can see, even for a little bit more complicated tests, we're able to create these helper methods, assert on the things that we need to assert on, and use a scenario that's pretty close to the production scenario, which is great. So now that we've got all of our infrastructure up in place, let's create another set of tests for the update to-do list, just to see how easy it is now to write these tests. So if we come back over here, we've got our update to-do list command, and it's basically going to, grab the entity from the database, throw an exception if it's not null, otherwise it's just going to update the title and save the changes. So let me create that. So we'll call it update to-do lists tests.cs, and I will not bore you with any more of my typing and just paste that whole block in, and we'll have a walk through it. Okay, we'll just bring in the namespaces. There we go. Okay, so we're inheriting from using static testing because that's where all of our helper, sorry, not inheriting, we're using the using static testing directive, where all of our helper classes are. We're derived from test base, which does our cleanup before each test runs. So the first test we have is that it should require a valid to-do list ID. And so we can't update a to-do list if it doesn't exist. And obviously this doesn't exist because the database is going to be empty. So we run that and we assert that it throws a not found exception. Good. Okay, next, should require a unique title. Obviously, this is quite similar to the one that we created before. So we're expecting it to work. The only difference being is that it does a slightly different check because it checks to see that the title is unique for the items in the list, excluding, the current item. That's working. And then finally, should update to-do list. So this one will, grab a user ID, create the to-do list, update the to-do list, and assert on the results. So that's it. We can really write our tests in a simple, kind of concise and clear way. And anytime we need to add some new helpful functionality, we can pop it in here. And we can also control individual test setup and cleanup within TestSpace. And just to be clear, my favorite thing about NUnit was really this one-time setup method because it really made it easy to manage that global test state, which is very important for tests of these kind. So let's run all those tests, make sure they're working well. Good, done, running relatively quickly for 7 tests. So let's continue. All right. So now I have some resources to share with you if you're keen to learn more. First, there's the Clean Architecture Solution template. So we'll go and have a quick look at that. I'll find it. So the Clean Architecture Solution template was created by me. It was actually created last year around this time for NDC Sydney for my talk there. And so basically, when I first started talking about cleaning architecture, I was talking about Northwind Traders and the sample solution that I built there. But I spent so long working with the community, you can see, there's a lot of people contributing issues and pull requests and following this repo that we had a lot of interesting discussions and we had a lot of interesting contributions. So I ended up building the Clean Architecture Solution template because Northwind Traders was good as a clean architecture example, but this is much better for actually creating new solutions. You get that experience where you can go .NET new CA solution from the command line. You can see in here, we've got a few more tests for you to have a play with. So this is the Subcutaneous test library. I'll probably change that name. And we also have some application unit tests and some domain unit tests there. So there's a lot more that you can kind of see there. Next resource we have is the Contoso University resource by Jimmy Bogard. And this one is very cool. It provides an example of writing these style of tests using XUnit. So I'm using NUnit, Jimmy Bogard's using XUnit, and so you can see how to write it using XUnit. So right in here inside of Contoso University integration tests. So that's a really cool approach as well. And following that, we have the Fixie demo. So I mentioned that I was very interested in writing these style of tests using Fixie. That actually came from a recommendation from Jimmy, who said, you kind of have to jump through quite a lot of hoops to write this style of tests with XUnit because it's just not very good at managing those globally shared resources. So I was pretty keen to use Fixie. Actually, I went ahead and created a .NET Core project template for it. So if you're interested in using Fixie, there is a project template you can use, and I think it's just .NET new Fixie from the command line after you install it. And what I really liked about Fixie and kind of the Fixie demo is that Patrick Lloyd created a lot of good documentation around this approach to kind of describe, what the goals were and what they want to avoid and what they want to do better. So this is really cool to check out as well. One of the things that's really cool in this particular one is it actually uses a diff tool when comparing the results of the tests. So that's a fairly nice, unique experience that's worth checking out. So you can see that no matter which framework you'd prefer to use, you'll have a good example for getting started. So NUnit is in the Clean Architecture Solution template. Contoso University is XUnit, and Fixie Demo is the Fixie test framework. And so both of those frameworks were a big inspiration for the solution that I put together in clean testing. All right, so in summary, today I've shown you that clean tests are simple to create, maintain, and understand. And these tests were configured to run the production services against a real database. And that helped verify the behavior and the integration for the test that we created. We use testing tools such as mock, fluent assertions, and respawn, and that helped to improve the simplicity and productivity of the tests that we wrote. And this approach resulted in better test coverage and higher confidence. So the confidence to deploy your system to production, knowing that it was going to behave as expected. Thank you. I appreciate everyone who came and attended. I will drop out now to the Slack channel